Salvador works as a food delivery driver and a server at a restaurant. He has up to 40 hours to work each week. He must work at least as many hours as a driver compared to as a server, and the hours spent working as a driver or less or equal to twice the hours spent working as a server. So what we're asked to do here are figure out A, what are the decision variables, and then we'll be asked to find the constraints and graph. So our decision variables here. There's two unknowns, X and Y, the number of hours he's working as a driver, and the number of hours he's working as a server. So those are his two jobs. That's what we're looking at. Okay? Part B says to list the constraints on his working hours. So again, X was driver and Y was server hours. He has up to 40 hours, so he can't work any more than 40 hours in total. How do we express that as a constraint? Maximum of 40 hours total? Well, quite simply, that's X plus Y is less than or equal to 40. The total number of hours driving and serving together, 40 hours or less. We've got a couple more constraints here. We've got that he must work at least as many hours as a driver compared to as a server. So he's got to work either the same amount or more as a driver than he does as a server. Just specify here, or equal. As it says, at least as many, not necessarily more. So the number of hours as a driver, which is X, has to be greater than or equal to Y, the hours as a server. And then we've got this last sentence here. The hours spent working as a driver, which is, again, X, less than or equal to 2 times the number of hours as a server. So driver hours X, less than or equal to 2Y. So the difference with this type of question here is that we don't always have X's and Y's less than or equal to some number. We can have constraints where X is compared to Y. X is bigger than Y or less than Y, and it's not an absolute value of they have to be together less than or greater than some number. Lastly, X is greater than or equal to 0, Y is greater than or equal to 0. Can't work negative hours. Part C, sketch the inequalities and identify the feasible region. So, once again, we're dealing with X is greater than or equal to 0 and Y is greater than or equal to 0, so we're only working in quadrant 1 once again. So let's graph our 3 other inequalities. I've got X plus Y is less than or equal to 40. That's this blue region here. So everything down in this bottom left-hand corner is at this stage feasible. I've got X is greater than or equal to Y. So now, remember, we're going to look at the intersection of all of these regions. So the first region was over here. The next region is here. And the third and final region, X is less than or equal to 2Y, is this region up here. So I've just drawn them all separately so that you can get a sense as to what they all look like. But now we'll combine them all together. So I've got X plus Y is less than or equal to 40. That was that region there. I've got X is greater than Y. That was this region here. So at this stage, it's this bottom triangle that's been in both regions. And then for X less than or equal to 2Y, I've got up here. And the only area that's in all 3 regions is this little wedge right here. So we label that. That is our feasible region. This little triangle in here. Just in there. That's it.